This lesson is on significant digits. Hopefully this is review since we focused a lot on this last year. First off, we're going to be focusing on learning how to calculate the number of significant figures, and then what happens when we do math, primarily algebra, with significant figures, because the final result must still pay attention to significant figures. First off, why significant figures? Significant figures are associated with the precision of a measurement. There is a big difference between measuring something to be 1.5 meters. Okay, it's about 1.5 meters, maybe about 5 feet or so. Okay, versus 1.5001 meters. It's like down to the 10th of a millimeter. Okay, so I can measure something down to a 10th of a millimeter, but do I really care that it's got that precise? So when I really say 1.5 meters, what I really mean is 1.5 plus or minus 0.1 meters. Okay, you know, somewhere between 1.4 and 1.6, I'll be happy. If I'm saying 1.5001, I need to be a lot more precise. I need to get out that meter stick that's measured all the way down to the millimeters, and actually down to the 10th of a millimeter, because that means 1.5001 plus or minus a 10th of a millimeter, 0.0001 meters. By using significant digits, we're really approximating the number versus the more precise version where we have to take those uncertainties, the plus or minuses, and propagate those through math. We'll do that next year, but in the sophomore physics, we don't do that. So, calculating significant figures. How many significant figures are there in a number? It's pretty easy. You just count up all the digits. Okay, 124.5. Okay, there's 4 digits. Okay, you see them here. You have the 1. Whoops. You have the 1, the 2, the 4, and the 5. Okay, 4 significant digits. Any non-zero number is going to be significant, and any zeros that are not leading zeros are going to be significant. So in 120.5, there's 4 digits, the zero's in the middle, that also has 4 significant digits. However, 0.001245, those first 3 digits are 0, they don't count. So this number has 4 significant digits also. Trailing zeros are significant only if the decimal point is specified. It's kind of annoying, so you have to look for that decimal point, pay attention to it because it makes a difference. So both of these numbers, 120.0, yes, the 0.0, there's a decimal point there, it's significant. And the trailing zero in 0.001240, that last 0 is also significant. So all of these numbers have 4 significant digits. It's important to note, however, that if the number was simply 120, no period, no decimal point, that would only have 2 significant digits. It's a lot easier when we use scientific notation. Scientific notation helps us by eliminating all of those zeros, especially for really large numbers or really small numbers. So any number, all of the digits before the multiply times 10 to the something, all of those digits are significant. So the exponent part, not part of the significant digit calculation, so 9.81, yes, you can say times 10 to the 0, has 3 significant digits, the 9, the 8, and the 1. So, how do I do calculations with significant digits? Multiplying and dividing, I think, is actually easier to calculate significant digits than adding or subtracting. So when I multiply or divide, I just count up the significant digits in all the numbers. Here I have 2 numbers, 9.81, 2,500. Okay, 9.81, let's see, 1, 2, 3 significant digits. 2,500 has 1, 2, 3, 4 significant digits. Oh, hold on. Those trailing zeros, there's no decimal point. It only has 2 significant digits. When I multiply it all out, I end up with 24,525 newtons. But I need to round to the smallest number of significant digits. In this case, I need to round to 2 significant digits. And so I round 24,525 newtons up to 25,000 newtons. Okay, since my second calculation was 2,500 kilograms, I don't need it to be that precise. I don't need to go 24,525. It's actually lying when you say, well, the answer is 24,525. It means, yeah, you know it's going to be that. You really don't, because that 2,500 could have been 2,505 or 2,480. Okay, so that's why we do significant digits. Okay, however, that 24,000, if I'm using that 24,525 in another calculation, don't round it. You're losing information by doing that. I suggest storing that number in memory or writing it out to about 6 significant digits before using it as an intermediate calculation. Now, adding and subtracting is a little more confusing, okay? But when I add numbers, I round to the tens place corresponding to the more significant number. So for example, I have the numbers 12.15 plus 0.1 meters. Okay, 0.1, I'm not counting how many significant digits. Okay, yes, 12.15 has 4, 0.1 has 1. What I'm looking for is which number ends with the highest tens place. In this case, 0.15 ends in the hundredths place. 0.1 ends in the tenths place. So I want to round to the tenths place, okay, the 0.1. So when I add it together, 12.25, I need to round that up to 12.3 meters. Again, don't round any intermediate calculations. If it's a mathematical function, like I'm doing a sine or a cosine or a log or a square root or something like that, okay, don't worry about that. Use the rules for multiplying and dividing. However many digits there are in the number, round that to the least number of significant figures. It gets a little more complicated. We'll use slightly more complicated rules next year. It's the same rules that we would do if we're doing IB Chem or IB Physics. Thank you.